Hello from sunny Massachusetts, and welcome to our webinar on how to visually model large data sets. Thank you for spending time with us today. We have a lot of really interesting material to present, so I'm going to jump right into it. I'd like to start off by introducing our speakers, myself and Dan Williams. I've been around for a while. If you've attended other of our webinars, you've probably heard my voice before. I've been doing graph visualization for about 17 years now, and I've written a book on the subject called Visualizing Graph Data. I spend much of my time working with our customers at KeyLines and helping them solve some of their graph challenges, and I'm based out of our US headquarters near Boston, Massachusetts. The British accent you'll hear on the line is my colleague Dan Williams. He's the product manager for KeyLines, and he spends a lot of his time figuring out how to continue to improve the KeyLines project to provide the best possible experience for our customers, and he's based at our global headquarters in Cambridge, England. A quick note on questions. In the GoToWebinar interface, there's a Q&A panel that you can use to ask questions. We'll address as many of questions as possible, given the time online, and if there are further ones that we don't get to, or if they're off topic, we'll follow up individually afterwards. The session is being recorded, so we'll be sure to send around a link should you want to watch this session again later, after the fact, or share it with other people. So here's the agenda for today. I've already done introductions. What I'll do next is outline the problem that we're going to discuss, how we're trying to go from a gigantic volume of data down to a more manageable size, and how there are different techniques that can be used at each stage of a funnel. I'll hand it off to Dan to go into detail on each one of those stages and under what circumstances one of those techniques might be the most useful. So over the past 7 years, we've built KeyLines with a focus on visualizing connected data. We've discovered that that's an incredibly valuable technique in very different fields, such as law enforcement, anti-fraud, cybersecurity, supply chain management, and healthcare. The picture on this slide is one example of link visualization telling a great story, and we've been using this example for years. This picture is a great example of how we can get insight from a visualization by making it clear who the most well-connected individuals are in a complex network of communications. But that final step from visualization to insight is really only one piece of the puzzle. Look at this picture. It's almost too perfect. It has just the right amount of nodes and links to convey a complex concept, but not so many that it's cluttered and unreadable. It's unlikely that your data takes such a perfect form. So what we're going to be talking about today is the path that your data needs to take to get from its native format to something like what you see here. So let's talk a little bit about data volumes. I sometimes cringe when people use the cliche big data, but it is a cliche for a reason. Collecting data in virtually any field has become so cheap and easy that many organizations find themselves collecting large volumes of data without any clear picture on how they intend to use it. And it's not uncommon these days to talk with people who have data sources running into the terabytes or even more, with billions of potentially interesting data points. There are already lots of visualization tools that can help aggregate this data, and those are good for answering demographic questions like how many of my customers are aged 30 to 45. But that misses out on the connected aspect of the data. Connected visualization of data and analytics need to focus on the individual data elements themselves. Unfortunately, at the end of the day, the insights have to be derived by humans, at least for now. And we humans are not big data creatures. If I were to show the image on the right to you for 30 seconds and then remove it, you'd likely be able to remember somewhere between 4 and 7 of the images. Presenting a graph on the left to somebody isn't likely to really generate any interesting insight. So how do we get from the billions of data points down to the few dozen that are going to provide that brilliant insight to human analysts? So speaking of brilliant insights, instead of trying to answer that question myself, I'm going to hand off the webinar to my colleague, Dan Williams, to tackle that question.
Okay, fantastic. Thanks for the introduction, Corey. Yeah, my name's Dan Williams. For those who don't know me, I'm the product manager for KeyLines. And I'm very much looking forward to today's webinar, if nothing else than because It's a question that I just get asked all the time. How much data can you visualize in KeyLines? How can we deal with and then insert a very large number of nodes into the question at that point? So I'm very excited to talk about some of this stuff. Hopefully you'll get some good ideas from this, and I hope it'll help you think a bit more about your data and bridging the gap between a database and a visualization. So let's get into it. This picture here is what we're going to talk about today. I'm calling it the data funnel. And whatever that number is at the top, that's how much data you have in your database. We're going to talk today about how you get it down through the numbers to something small enough for human analysts to process and get insight from. And at some point, as you go down that funnel, you're going to be making a transition from the things that you're doing at the back end on the server side and the things that you're doing in the front end, typically in your end user's web browser. So I'm drawing in green the stuff that's happening in the front end, in black the things that are happening on the back end. KeyLines, of course, this is the new KeyLines logo for those of you who haven't seen it, but KeyLines lives very much in the front end. And so we talk a lot in our webinars about the things you can do in a visualization to remove clutter. I will talk a little bit about those today. Filtering, combining, and pruning are really good examples. But most of what I want to spend the time on today is more about this back-end stuff. And the visual data modeling part is intriguingly colored in both black and green, because the answer as to where you do that can depend on your situation. But I'll give you some good examples that'll help you figure out what makes sense for you. So let's start at the top of the funnel. Let's talk about your raw data in your database. Let's assume it has at least 1 million data points, maybe many, many more. Where do we start? And the most obvious point to start is filtering. And probably almost everyone here, if you built an application to visualize a database, you're already doing this. So what do I mean by backend filtering? Well, here's some common approaches. A really common way to start is that the visualization is not a visualization of your entire database. Of course, it begins with some kind of search. So here you can see, for example, I've searched for a person's name, and that person, that entity is extracted from the database and visualized. And quite commonly, people bring in the nearest neighbors, perhaps, so one hop. Sometimes you bring in 2 hops, often it's 1 hop. And so this is kind of a starting point. So already, even if there were 1 billion nodes in my database, I've only got a dozen or so on screen straight away. So filtering, obviously, where it works, is an incredibly effective way to cut out data. But in practice, it doesn't always work like this way. Usually a couple of things happen. So one thing that happens is that you allow your end users to bring in more data. These little blue plus signs are quite a common way of doing this. It tells the user they can maybe double click or something and bring in the neighbors of the next nodes and bring in data bit by bit. So that can often result in a huge amount of information coming back. Another scenario is maybe a search like this isn't the way people do it. Maybe it's more of a complex query. Sometimes the analysts come in the morning and they're presented with a list of alerts or issues they need to look at, and maybe they bring all of those in. Or maybe they're able to ask more complex queries like, find all insurance claims from the last month which have a certain status or something like that. And of course, there's no guarantee in those situations that you won't get 1,000 or 10,000 or 100,000 data points coming back at that point. So it's always a little risky that filtering is not going to be enough. Now, one solution for that we often see is if you're going to get a whole load of data back from your query, the application says, well, are you sure? Or maybe it says, that's too many records to bring in. We're just going to bring in the first 50 or something. And that's okay. I'm not a huge fan of that approach, particularly putting an artificial limit in there, because for one thing, if you're only bringing in 50 nodes out of 1,000, well, which 50 are you bringing in? And what happens if we're hiding insights because we haven't brought in the information that would have contained that insight? So in general, I'm not a big fan of this bottom one, although it's a very, very easy way to make sure you only get 50 data points on the screen, as if you limit it. But what we want to talk about today is more techniques to avoid having to do this and to avoid this problem. So let's assume we're going down our funnel. We've got our data down to maybe a few hundreds of thousands of nodes by some intelligent filtering, but we still have too many really to show on the screen. What else can we do? So this is where you start having to do a bit more work yourselves, unfortunately. And a really obvious one is data cleansing. I'm calling this back-end aggregation. So a lot of information at the back end could be aggregated before it ever gets to the end user. And in some cases, data cleansing is really what you would call this. So, in this example, I had a database. The data is inherently dirty and ugly. It's got a lot of things in it that the end user doesn't really care about. In this particular example, we've got a bunch of aircraft, and let's say the user has started their search with a search for Boeing 737, for example, and what they just want to see is one node representing a Boeing 737 and explore outwards from there. But in this case, the data has more detail than that. It has lots of different variants of a Boeing 737 in this little example. And so immediately I've got 8 nodes appearing on the screen representing one thing. And although these might be perfectly valid data points, if you wanted to compare different variants of Boeing 737s, maybe in this particular application, there's really no need to do that. And it would have made much more sense to aggregate those on the back end and send one node out to the user. And you can imagine this scaling up if you had a database of aircraft or something else. You can easily overwhelm people. So cleansing or tidying up of the data on the back end in order to maybe represent many nodes as one is something that could help cut down those initial numbers. It's not just nodes. You might want to aggregate links. Here's a really common example. This is a data set of email communications that we're visualizing here. And each person sent emails to various different people, and it's very possible that over the period you're looking at, these people might have sent hundreds or even thousands of emails to each other. And the naive way to model this would be to say every email is a link, and so when I draw the picture, I'm going to see 1,000 links between these two people, which would result in a very messy visualization and wouldn't really add any insight. So what we did in the demo that this is based on, and what a very good idea would be to say, let's, instead of representing each email as a link, let's roll those all up together and say the link represents all emails between these people. And let's put a property on that link, property of 1,000 in this case, if they send 1,000 emails. And then we can let the visualization, we can let KeyLines decide how to render that. And we could just do nothing, we could just draw a link, but we could do something clever like make the link thicker if it represents more emails, or use a color scale or something. All of that styling can happen on the front end, but the key thing is that at the back end, we've only sent one single link over to the application at the front instead of 1,000. And again, you can imagine how this would scale up, a very easy way of getting down from large numbers of nodes in the data funnel to a much smaller number by doing this. Now, what we're getting into now is something a little bit more than just aggregation and cleansing of data, because we've made some quite big design decisions here. We've said that we're going to represent links with thickness or color, and we're going to render things differently from how they're stored in the database. So this gets us onto the main topic of what I want to talk about, which is creating a visual model. And as the picture shows, you can do incredible magic if you figure this out, but you do have to do a lot of work. It's not going to come for free. You're going to have to work hard at it and think about how your data can be modeled. By modeled, I mean changed around. What you store in your database does not have to be what's at the front end, but if you get it right, then you can really do magic. So let's have a look at a few examples of the kinds of things that I mean. So the first thing is models where we're basically saying the visual model of my data is a subset of the actual data in the database. So for example, in your database, you might have, and I've got an insurance themed example here where we have people linked to their phone numbers, people have policies, they make claims on those policies, the claims involve vehicles, the claims involve damages, maybe the claims involve witnesses and third parties and so on. So that's my raw data model on the back end. If my end users are just interested in investigating people who have multiple policies or something, and then really they're only interested in these two kinds of node. So a visual model could simply be, let's only visualize these two types of node and the links between them. It's kind of a filtering model. we filter out most of what's on the back end and just bring in the nodes of interest. That's a little simplistic, but obviously very effective at getting us down that funnel. There's other things you can do too that are more advanced. I'm going to show some demonstrations of all of these, but one idea that you might not have thought of is replacing nodes with links. In the example on the left, we have blue nodes are movies and green nodes are the actors in those movies. So you have actor is in movies, movies contain actors, and so on. On the right, we've got exactly the same data, but instead of showing movies as nodes, we've got rid of those and we've drawn a direct link between actors. And we've said, let's link together actors who have a movie in common. So the name of the movie now kind of could appear as a property of one of the links as opposed to a node. That means we have half as many nodes, or roughly half as many nodes. We've got a lot more links though, so it may not be the right answer, but you can see if what you're trying to do is spot who are the important actors who bridge different communities, it's an awful lot easier to tell it from the picture on the right than the picture on the left. And potentially we brought back a lot less data from the back end. So remodeling the data to say that even though my database stores it the way it's done on the left, I'm going to send it to my users in a different way for visualization on the right, is another example of data modeling. And finally, as another kind of example, is where we talked about replacing nodes with links. We talked about replacing links with link styling. Here's an example where we're replacing nodes with glyphs. So the glyphs are these little decorations. And what we're doing in this case is we're saying, okay, I've got a database on my back end of people, and I'm interested in knowing how teams within an organization communicate with each other. So I don't really need to show the individual people. In fact, you might not even be allowed to show the individual people if you've got privacy concerns and you want to summarize over teams. So we represent a team with a node, and maybe we let you know how many people are in that team with a little counter like this, or maybe by changing the size of the node, or maybe with some kind of pie chart or donut effect. There's lots of things you could do to represent the fact that there are really 9 or 50 people in a particular team. You don't have to bring all of that information over to the front end and render it at all. And this is really what I want to get across, that the easy thing to do is to just point your visualization at your entire database and say, visualize it as it is. But you don't have to do that. You can model things differently. So I want to show you a few examples of this running live, just so that you get a feel for it. And again, I'm going to use my insurance claim example as an example for that. So I have a very small section of a data set here. Let's imagine we've got my data funnel. I've got millions of data points, and I've started out by saying, just show me insurance claims in my city of Cambridge in the last year or something. So I've got it down to a much smaller number of nodes by that initial backend filtering, but there's still a lot of data here. And your typical insurance claim might look something like this. As I said before, a person, a policy, a claim, some damages, some people, and so on. But what you tend to get, and what I'm sure those of you who've tried to visualize this kind of data before will be familiar with, is these big tangled hairballs of information. In this case, because we're putting garages, these garages have maybe fixed lots of damages in their time, and most of those damages will have had insurance claims associated with them. Then it's going to be completely normal that if you look at a garage, you're going to see a huge starburst of information about that garage, because it's just got a lot of information connected to it in your database. And there's nothing wrong with that. This is a perfectly sensible data model to store our data in, but it doesn't help the end user. And you can imagine if instead I said, find me all insurance claims in the UK in the last 2 years, instead of just around Cambridge, then I'd already have hundreds of thousands of nodes trying to get into my visualization, and we'd be struggling. So what can we do? What I've done is I've just set up a few of these different visual data models in here to show you the kinds of thing. And this is another point. You don't have to have one visual model and figure out what the perfect visual model is. You can have several, and you can let your users switch between them, and that's what I've done here. So let's look, for example, at a simple model where the filtering model, so where I only care about policies and people. So when I switch to this model, what you can see is everything else disappearing, and now my data has been remodeled, so I only see people and their policies. This kind of thing might be useful for looking at questions purely related to people buying policies, such as this suspicious character here who has increased the value of his insurance policy very heavily just the month before he made a claim, which might make you suspicious that he's been planning this claim in advance. So I can switch to people and policies, but I can also do something a bit more advanced. If you remember, I showed you that example with the movies where I replaced nodes with links. Let's try and do something similar. So here's a model where you can see in my raw data here, people are not linked directly to garages, for example. People have policies. Policies involve claims. Claims were fixed at garages. But what I could say is, give me a model involving people and garages. And when I switch to that model, you can see that we've made these kind of virtual links between people and garages. A person is linked to a garage if that person had a claim which referenced that garage and its expenses. So those links have now been shown. We've got a much simpler model. And again, why might you do this? Well, in this particular case, it's because we're investigating fraudulent garages. And you may not spot anything suspicious on this picture here, but if I put this data on a map, so again, remodeling it, so now we're showing it on a map, we can see that typically people tend to go to garages that are close to where they live. But in this case, we've got an awful lot of people traveling quite a long way to one garage, maybe because that garage has been very helpful in inflating their insurance claims for them, for example. And it's the kind of thing that would be very hard to spot if you didn't have those direct links between people and garages, and those links aren't in your original data set. One final example, or a couple of final examples here. One thing I can do is have a model just with people. So what's going on here? People aren't linked to people. Well, we can link people together who are involved in the same claim. So all of these people are involved in one claim. Maybe one of them is the person who made the claim and the others are witnesses or third parties. So you might have a kind of a typical picture on the right, and then here on the left we've got something more unusual where you've got somebody who's involved in an awful lot of claims, and you might be suspicious that they would be some kind of professional witness or somebody who's making too many claims or something like that. This model, again, is not in your raw data. It's a much simpler view of the data, but it's a good way of exploring it. And again, it's helped us reduce the data set from potentially hundreds of thousands to a much smaller number. And the final example I mentioned was glyphs. So let's have a look at garages and damages. So here I've linked garages to the damages they fixed. A typical view is going to be one of these big starbursts. And this is something you're going to see a lot in your data, that certain kinds of queries result in these starbursts where there's just loads and loads of nodes. And this is only a small number, but you can imagine that there could be thousands here. What do you do with starbursts? Well, one thing you can do, and I'll talk more about them in a second, is combine these and group them by some kind of properties. So it's not very interesting to look at damage 283, damage 524, but if we had some data on those damages, such as what kinds of damages were they, we could group these together. So I can do that here. I'm doing this visually because I want to show you what's happened, but you could be doing this on the back end before it ever reaches the user. So here you can see I've grouped the claims now by what kinds of damages are they. And we can maybe find some interesting insights, like this was a real story. There was a garage who was inflating claims, and they had no imagination, and so they were always adding a fix to a rear offside door, and the insurance company got wise to it because they didn't have the imagination to invent different damages every time they did it. So there you go. That's a few ideas. And remember, all of these visual models, you don't have to pick one. You can toggle between them. It can be a very nice experience to toggle between them. And it all helps you get down that funnel from potentially hundreds of thousands of data points after you're filtering to a much smaller number. So just to remind you of that funnel, here it is again. So we've been talking about this visual data modeling. Ideally, you want to do as much as you can on the back end to avoid slowing things down by sending them down the line. But of course, if you want users to be able to switch between visual models, then you might want to leave some of that to the front end. In my example, we actually used KeyLines' graph capabilities to calculate that model involving the people, so that it could work out on the fly which people were involved in a claim and connect them to each other. which means you can nicely toggle back and forth. Or you could do that calculation on the back end and just send the data over to the visualization when it's already pre-processed. And that's certainly what you want to do if you're using it at this point where you're going down from hundreds of thousands to tens of thousands of nodes, and the connection of which is sending the data might become a bit of an issue if we're waiting for large amounts of data. So once you've got to about 1,000, or the order of thousands, that's the point where you can start showing data on the screen. Really, we'll talk. KeyLines, can render pretty performantly with higher numbers further up the funnel, but the end user, as Corey said at the start, can get pretty overwhelmed with anything more than a few tens of nodes. So really, we see the front end techniques like these particularly come into their own once you are kind of no more than a few thousand nodes, ideally more like a few hundred. So let's have a quick look at those and see how they help. So I want to talk about three today: filtering, combining, and pruning. Filtering, we talked about filtering at the back end. Ideally, you filter as much as possible out so it never comes to the user in the first place. But you definitely want to give your users the ability to tidy up what they see as well. So filters are very common in applications that we see built with KeyLines. And some examples, some tips here. One tip, often what people do is they turn off the filters by default. So by default, you see everything, and then the user has to clean up as they go. It's definitely worth thinking about whether you can flip that on its head and allow the user the ability to bring things in. So bring the data in, but don't show it on the screen. Have it pre-filtered and let the user change the filters. Another tip on the right here is combining a filter with a legend. You probably need a legend for your graph. You probably need a filter too. So an obvious UI improvement would be to combine the two. Here you can see we've done that. We've used these colors to represent the different airlines in this case, and we have filters to switch them on and off. And maybe we've turned off some by default. Really, how do you know what to turn on and off by default? The only answer is talk to your users. Find out what are the kinds of questions they ask. What are they typically doing? It could be that 80% of the time, they only are interested in a certain fraction of the data, and you could make that the default filter. In this case, we realized that the end users are really only interested in the busiest air routes. So we actually put in a filter that filtered out flights that were not particularly busy, or routes that didn't have very many flights, so you can only see the major air routes. If the user wants to show them more routes, they can drag the slider and change it. But most of the time, the kind of problem they were trying to solve didn't involve showing all of these flights. So we were able to set the filters up in a way that gave them a pretty good guess at the visualization they wanted, and they could bring in the clutter themselves if they needed it. So definitely think about what your users want to see first. Allow them to bring in mess if they want it, rather than giving them the mess and expecting them to clean it up, I think would be the top tip there. So that's filtering. That can get you down to hundreds or tens of nodes in most situations, but sometimes you can't, and that's often because of this starburst problem. I mentioned combining before. In my example, I combined it by types of damage. Here's another example where we've combined data by type. So this is an aircraft. It's linked to a whole bunch of data on air safety, accidents, and locations, and operators, and so on. And there was something like 500 or 600 nodes connected to this one, which was just overwhelming. I'm only showing a small subset of them here, and it's still overwhelming. If you look at the view on the right, it's a much nicer view of the same thing, where we've combined things together. And do you do this on the back end or the front end? It entirely depends on whether you want to give your users the ability to drill down and look inside these groups. If you want them to look inside it, then KeyLines has this fantastic combos capability that lets you do that. So here you can see an example where we are just kind of drilling down for more detail. So it starts out here at a very high level, and the user drills in and opens up layer upon layer, gets more information when they want it. So in that case, we're using combining at the front end because we want the ability to look inside them. But if you know they're never going to need to look inside them, then consider doing this combination at the back end. So the data never even has to get into the graph at all. And the final example was pruning. So pruning, again, it's that same theme of tidying up as you go. So ideally, you don't give them a mess, but sometimes inevitably they do, and you want to make it easy for the user just to tidy things up. You're very likely giving them buttons to lay out the graph as they go so that they can make it look tidy. Another quite nice one is this effect, which is pruning. So what we're doing here is removing what are called leaf nodes. So what happens here on the screen, we have a lot of leaf nodes which are not connected to anything else, and often they're the least interesting ones. And those starbursts are, usually mostly made up of leaf nodes, things that don't connect to anything else. How you do that is up to you, but in this situation, we've allowed a double click on the background just to be my kind of tidy up interaction. So whenever I double click on the background, it fades out all those leaf nodes and tidies everything out, so I only see the highly connected information. It seems to make people a lot happier if they can keep things tidy as they go. You can always make these effects undoable, so that if they change their mind, they can bring the data back. But again, giving people the ability to tidy things up can make a big difference. And by this point, you would hope that the user can have gone all the way down that funnel from potentially hundreds of thousands of things to just a very small number. Okay, so just wanted to kind of summarize there what we talked about. We've gone on this journey. There's no right answer, I should say, to exactly where in the funnel you do what. But typically, I would think about it in this kind of order. So I would first start thinking about what kinds of searches or querying do you want to give your users to try to get them as easily as possible to the small subset of data that they're going to be interested in for their investigation. Filter as much out before they even start. Then I would definitely think about, is the data in your database a faithful representation of what you want them to see, or can you aggregate information together so you summarize it for your end users? That starts to get into this area of visual data modeling. So how do you actually want to see the data? Just because it's a bunch of rows in a relational database table in your backend doesn't mean to say each row has to correspond to one link. It could correspond to, you could have 1,000 rows representing one link. Or just because you have a graph database and there's a particular item is represented as a node in your database, think about whether that could be represented with color or with a glyph or with something else in the front end. This is where you have to do the hardest work, but it's really valuable stuff because you can make the difference between 100,000 things appearing and just 100. And then finally, give the users the tools they need to filter and combine and so on to put them in control. And the answer to the question, where does this happen, really comes down to how much control you want to give your users versus how much do you want to just not make them think and bring the data in straight away. Okay, I hope that all made sense. I think we're going to move on to the question section right now. So I will hand back to Corey, who's going to ask the questions, and please do send in any questions you have on the Q&A feature of the GoToWebinar.
Thank you, Dan, for that brilliant insight. We had a few questions submitted in advance, so if you can move to the next slide, we'll take a look at those first, and then we'll look at any in the panel that you've submitted during the session. So the first question, I'm interested to see how users can filter and change the view of large complex graphs to focus on the information they are interested in. Hopefully that was the point of this presentation, but Dan, I don't know if you have a few nuggets of insight you want to just throw out.
Well, yeah, I think hopefully we have covered that one. That was asked in advance, so hopefully you saw what you wanted to see. I mean, again, I would just echo that point that you can allow users to do that, as the questioner says. You don't have to decide everything for them. You saw that example where we switched between models. I think the key thing here is really talk to your users. As I said before, find out what they want to do and then work out how to model the data to suit them. Don't give them everything and expect them to figure it out. Ask them what they want and improve the data to meet their needs.
Okay, the second question you can see there, where is the best place to calculate those visual models, on the front end or the back end?
Yeah, so again, I talked a little bit about this. I guess I would say that, do as much as you can on the back end, because of course that has loads of performance benefits generally, but only if it doesn't impede the user experience. Actually, in the demonstration I showed, there's 3 different ways you can do this, and I had examples of all 3, even though you probably wouldn't have seen it. So one thing that you can do is do it completely in the back end. That modeling where I connected together garages and people who weren't really connected. I could have completely changed my data in the back end and then just sent the new graph over to the end user, but that wouldn't have been great because it would have been a big time lag every time I changed that little drop down. So I want to do some of that at the front end. Actually, what I did though was did all the complex graph traversals on the back end. So I worked out all of the links, the virtual links as I call them, pre-calculated them on the back end, sent them over, and when the users switched that drop down, all I did was I just had each one of those links and nodes was tagged with which models it should be shown in. So all I'm doing when the user picks them that drop down is hiding certain links and showing other ones. So it's a kind of a hybrid approach. We calculate all the model on the back end, but we bring all the different models to the front end and let the user switch between them. And then the final way you could do it is actually calculate the models on the front end. That's what I did with that people model where I showed the important people. I used KeyLines graph functions for calculating shortest paths and so on, and actually did the modeling live at the front end. Downside to that is you've got to do more work in your application, your front end, but the advantage is that you can take advantage of KeyLines tools for doing that, and particularly if your data is coming from lots of different databases, or it's not coming from a graph database and you don't have those tools for doing graph traversals, you could make use of KeyLines and do some of that up front. So there's no best place. I would just say do as much as you can on the back end unless it impacts your user experience.
Okay, thank you. The next question I'll take myself. I sort of chuckle because this is a question I get from new users of KeyLines virtually every time, which is what is the maximum size graph that can be visualized with KeyLines? So there's a few different ways to answer this question. One is what's the maximum amount of data that you can visualize in KeyLines? And as Dan showed you today, depending on your model, that could be unlimited. You could have a single link on the chart representing hundreds of thousands or even millions of relationships in your data source. But as far as the purely tactical, how many things can you render in a chart at once, you're limited by a few different factors. One is by the amount of memory that you're consuming. So if you wanted to put billions of nodes and links on the chart in the browser at once, you wouldn't expect your browser to be able to hold all of that much information in memory all at the same time. But a more practical limitation is just around how much is realistic to present to somebody and expect them to get some useful insight into. So a little bit of the presentation today focused on that. We tend to, when we're talking purely from a technical standpoint, recommend that users keep their graphs under, say, in the tens of thousands of nodes and links. And that's just because the frame rate using KeyLines can slow down. But as you've seen, that can be well higher than the amount that's actually useful to present to an end user and expect them to be able to get any value from it. Okay, so that's beyond the questions that were submitted in advance. Now we're going to take a look at some of the questions that came up during the session here. So we have one from Sujit who asks, how is the logical model created in KeyLines from the underlying data source? And are there options to create a workflow?
Okay, so how is it created? As I mentioned just now, there's a lot of different ways you can do it. What I did in most of those cases was on the back end, basically, where my fictional data was generated, is I worked that stuff out. So for example, in my case, I said, let's link people to garages if the person had a claim and the claim was processed by a garage. So in order to work that out, if you have the advantage of having a graph database on your backend, then that kind of graph query is very easy to do using a graph query language. If you've got a relational database on the backend, then you've got to do something more complicated in terms of the joins you would need to do in your query to work that stuff out. But you basically you work out what the thing you're trying to match in your database is that you want to represent as a link. If you can do that in the back end, then you replace it with a link, which you then send over to the front end. So that's how that's done. When you say a workflow, I'm not sure exactly what the question means by that, so happy to follow up afterwards. If it's giving the users the ability to build the query themselves in the front end, then yeah, we do have some customers who's done some really neat things where they've allowed users to graphically build a query to filter data. There's nothing really stopping you doing that kind of thing. Ultimately, though, what you've got to do is just figure out how to query your database to get the information you need. Then you just have to turn it into a data set of nodes and links, which you then send to KeyLines, and KeyLines will display it. That's the basic idea. Specifically, is going to depend very much on your database and your model for interacting with end users. So happy to take that one offline with you if you want to discuss it some more.
Okay, thank you, Dan. I have another question from Joel. I'm going to summarize it a little bit here, but basically he's asking about attributes on both nodes and links, and how can you use those attributes to help your summarization, or how can you use those attributes to help control which things you're visualizing to get those insights?
Okay, yeah, so I guess when people talk about attributes on nodes and links, if they're talking about their database, they probably have some kind of property graph database on the back end if they already have nodes and links which have attributes. So if that's what you're describing, then in one sense you had an advantage because you already have that and you may be able to directly visualize it. So for example, if you have a person as a node and they have an attribute which is their nationality, then when you come in KeyLines, you could represent that nationality by showing a little flag of that person's nationality in the corner of their node. We call that a glyph. It's very easy to do in KeyLines. A very common one would be using color scales as well. So if you had nodes representing, I don't know, railway stations, and you had data about the traffic that passed through that railway station, you could color those nodes with a color scale representing that property. So yeah, if you have properties on your data, you can certainly do a very easy direct mapping of that property to something. KeyLines has a whole suite of tools. There's some nice galleries. You can look at node and link styling galleries on our website, which show you the kinds of things you can do: donuts, pie charts, link thickness, link color, node shape, icons, and so on. You could think how to do it. More challenging, of course, is if you're not doing it directly, but you're doing something a bit more creative, like I was showing you before, where maybe something is not a property in your underlying database. Maybe it's a node. A common situation occurs if you're using an RDF type database, a triple store, where pretty much everything is a node or a link. And if you do that naively, you end up with an awful lot of nodes and links. And what you actually might want to do is remodel some of those nodes and links into properties. So if you've got person connected to a separate node for their nationality, a node representing the UK, instead of showing that as a node, you might actually want to show it as a UK flag on the person in the visualization. So yeah, I hope that answered the question. Again, if I haven't quite interpreted it right, then feel free to discuss it offline.
One thing I might add to that answer is that it's very common that you may want to use the grouping or combining feature that Dan showed earlier and make those based on a common property. So KeyLines has built in the ability to assign any number of custom properties to both nodes and links. And it might be very likely that you might want to take all nodes that share a common property and group those together in those combinations that Dan showed you. And that can help reduce the amount of clutter that you're looking at on the chart while still maintaining the ability to drill down on those individual data elements inside of that group. So I think that that's all the questions that we got. There were a few that we didn't get to because they were a bit more technical in nature, but we'll certainly address those offline via email afterwards. Thank you very much for attending our webinar, and do feel free to reach out to Dan or myself afterwards if you have any questions that come up after the fact. Have a great day.